In class today, during math, we're going to continue our mathematical process standards and represent and explain fractional units. In other words, we're teaching fractions still. Before we get into our lesson, this is third grade, sorry. Before we get into our lesson, let's watch this quick little video. I just hit the... We're going to watch this video. Yes?
Kevin here. Let's split a pizza. I'll eat one half and you eat the other. I'm going to be using a laser guide and a protractor to make sure that it's perfectly mathematically equal, so that no one is complaining that one of us got more pizza than the other one. Okay, here we go. There we go. All right, let's just get this cutting board out of the way. Perfect. These are two exactly equal halves, so grab your slices. All right, I know that it doesn't look like it. Let's analyze how pizzas are traditionally cut. Pizza is usually cut right down the center through its diameter, and then cut again at a 90-degree angle perpendicular to the first cut. Two more cuts bisect each 90 to a 45 to make 8 equal slices. That feeds 4 people or 2 people equally, and maybe 3 if one of them just isn't as hungry.
That pizza did look good, didn't it? Now, the first time he cut the pizza, it may not have looked like it was cut in half, right? The slices were all wonky, some were huge, some were tiny. But the second time when he showed the pizza and how it's cut, all the pieces were sliced evenly. Just something to keep in mind throughout the lesson.
You may want to go to slideshow. See up on the very top, start show?
Oh,
Because I think it's just on your slides.
you're right. Slideshow. All right, let's go back, and that's why it didn't play. So let's talk about standards today. The same thing that we've been going through, explaining that two fractions are equivalent if and only if they are both represented by the same point on the same number line, or represent the same portion of a same size whole for an area model. Equivalent, number lines, area models. Have any of you heard any of those words? And it's okay if not. We will unpack some of those in a bit. But this is our standards over the entire unit. Let's talk about the objective for today. And our objective for today is to demonstrate an understanding of how to identify equivalent fractions using area models. Everyone read it with me. Demonstrate an understanding of how to identify equivalent fractions using area models. There's that word again, equivalent and equivalent fractions. I wonder what another word for equivalent could be. Well, it's like the same. So go ahead and get your math journals and your pens, and we're going to take some notes and go over some key terms here. So another word for equivalent is the same, but in our case, it's when two or more things are equal in value. And we're talking about fractions. So can anyone tell me what they think an equivalent fraction might be? Mia.
A fraction that is the same as the other fraction?
Yeah, a fraction that equals the other fraction. In our case, they may not always look the same, but they represent the exact same portion of a whole. The next term, it's not a new term. We went over these yesterday's lesson with our bar models, but just to kind of refresh our minds, a model is a picture or a drawing used to explain something. You know, as I said, we did bar models yesterday where it was just the strip and we divided the strip in our fractions. Today we're going to use what's called an area model. They look very similar, but they are different. And the area models are picture diagrams that we can use to split up to represent fractions. And the last one here, it's not necessarily a key term, but it's just our standard for demonstrating understanding. Now here in math, we know we understand something when we can work through a math problem to find the answer. You know, but how do I know you know? You could have just copied the answer from the person next to you. So in order for me to know, I need you to be able to explain how you got the answer. And when I can see that you can explain that to me, I know that you've understood. So as I said, this was yesterday's. We did the bar models, and we can see that everything was in a strip and divided evenly in the strip. Now today, during our lesson, when we talk about area models, they're very similar. However, some of them aren't in a row, and that's because it takes up the entire area of the shape. So although this one is a half, they could have cut it this way and it would have been a half, and that looks different than our bar models. And our 1/3, they could have sliced it this way and it still wouldn't have been the same as our bar models. But we will talk about squares later. Today we're going to focus on circle models, because those look way different than our bar models. Like this third one here, that's really weird. It's got like lines and angles and stuff, so we'll figure out how to divide these up. So during the lesson, we do have expectations. When I'm up here and I'm teaching, you are watching, you are listening, and you are learning. And then we'll go through a problem together. The teacher will model, and you all will follow along in your math journals. And then after that, you're going to do it with a partner or with a group. It just depends on what the lesson calls for. And after that, you're going to do this independently, and that'll be your ticket out of this class. So as of right now, I'm going to model a problem up here. All you're doing, you're going to put your pens and pencils down, and you're just watching, listening, and learning. So the first problem says, circle A and circle B are the same size. And we can see here, they're the same size. Are the shaded portions of the circles equivalent? Why or why not? There's that word equivalent, and that means are they the same? So the first step that we're going to do when we are breaking down this problem is, well, we have to figure out what those fractions inside of those areas are. So step one, let's read the problem to make sure we're looking for equivalent, non-equivalent, or it's asking us for something else. So again, are the shaded portions of the circles equivalent? Okay. Step two, identify your first fraction. So in circle A, how many sections is that circle divided up into? Who can tell me? Katsali. 2. We have 1 and 2. And how many sections of that circle are shaded in? Jennifer? 1. So we have 2 goes in our denominator because there's 2 sections there. And because one of those sections is shaded in, that goes on top for the numerator. Very similar to our bar models. Now for circle B, same thing. Who can tell me how many sections that circle is split up into? Andrea? 4. We have 1, 2, 3, and 4. So since it's got 4 sections, that goes down as our denominator. And Andrea, can you tell me how many sections are shaded in? 2. And that's our numerator. So 1 over 2, or 1/2, looks different than 2 over 4, right? Those aren't the same numbers. They're not 2 1s on top or 2 2s on the bottom. So our next step is let's figure out how to answer this question. When we're looking at these, we know that they're the same size, and we can see that the same portions of those areas are shaded in. So to me, those are equivalent fractions. The shaded portions of the circles are equivalent. And a way to explain it, and I know this is a very long way to explain it, and we have our sentence models on your papers here, but for me, explain how you came to the conclusion. So circle A represents 1/2, and circle B represents 2/4. With the same size whole, 1/2 is equivalent to 2/4 because both fractions represent the same portion of the same whole. So both fractions represent the same portion of the same whole. Now, let's work one together. These are 3 different pizzas, and we can see that they're all cut up into different slices. Are the pieces being taken away from each pizza equivalent? Why or why not? So what was step 1? Who can tell me? Mia. Read the problem. I read the problem, but it's always good to go through the problems again to make sure that we're understanding what we're looking for in the questions. Are the pieces being taken away from each pizza equivalent? Why or why not? So we see pieces are being taken away from the whole. Are those pieces equivalent? Step 2. Who remembers step 2? Ashley. Yeah, well, we're going to figure out what our fractions are. So let's start with our first one. How many pieces is this pizza divided up into? For time, I'm going to 2. So that goes as our denominator. And how many pieces are being taken away from that? 1. That's right. Now, the last problem we did, or when I modeled, I only had 2. This time we're going to have 3. So this next one here, very similar to the first one. We have 4 slices, and 2 of them are being taken away. That last one looks different though. There's more slices on there, and 3 of them are being taken away. So we have 6 total slices there, and with the 3 being taken away. All of those fractions look completely different from each other. But pizza 1 represents 1/2, pizza B 2/4, and pizza C represents 3/6. Each one of those has the same size whole, and 1/2 is equivalent to 2/4, which means 2/4 is equivalent to 3/6. So knowing that, is 3/6 equivalent to 1/2? Yes. And now you will work with your partners, your math partners, who are the people that are sitting next to you. And there's a sheet of paper between you, and there's a problem on there. And as you're working through these, bounce ideas off of each other. It doesn't matter how you come to your conclusion, as long as you can explain to me how you got the answer. If you have questions, ask your brain buddy first, and then if you can't figure it out, then come to me. Raise your hand, and I will come to you and answer your questions. All right, and skipped a whole section. Oh, no, I've lied. All right, so, class.
Yes.
All right, now that we're done with the group activity, what questions do we have about the assignment that we just did? I know he's dressed exactly like me. I did not plan that. So as a group, we would go through this, 3 things I learned, and I would just bounce ideas off of the students. 2 things that I found interesting, if you learned anything new today that you found interesting, and then 1 question I still have. And although it says 1 question, I would still take other questions if other students had questions. And once again, to go over our objective, we were demonstrating an understanding of how to identify equivalent fractions using area models. And I think that out of the discussions that we had, everyone here seems to understand how we got the fractions out of those area models and whether or not those fractions were equivalent. So now, you are going to work independently on your exit ticket, and once you are done with that, just bring it back up to me, and again, that is your ticket out of here. And the end.